welcome to the GGM YouTube channel. Today we will be doing systems of equations. So, might be a little bit basic, but next week we'll do more advanced topics. So, this is sort of an introduction to solving algebraic systems. So, what is algebra really? Algebra is the study of mathematical symbols and the rules for manipulating them. For competitions like AMC8 and math counts, you only need to know some basic algebra. So for this week, we'll just cover systems with equations, where you're given some equations with variables, and you're asked to find the values of them. So just a little bit of background on systems. A linear system is when the degree of all the terms is equal to or less than 1. So you may not have heard the term degree before, but what it essentially means is it's the greatest power of the variable in the term. So if there's multiple variables, the degree of the term is the sum of the degree of the variables. So for example, 3x has degree 1 because the greatest power of a variable is 1, and xy has degree 2 because there's 2 variables and each of them has degree 1. So overall they have degree 2. And a system of equations is when you have multiple equations with multiple variables and you're basically asked to solve for the values. And we'll discuss linear systems because they're a lot easier to solve. And you will generally not see non-linear systems on the AMC, but on the AMC 8. On the AMC 10 and 12 you would definitely see them now. So one of the methods of solving linear systems is by substitution. So consider the following system. X plus 2y equals 68 and x minus y is 35. So substitution is basically expressing one variable in terms of the other. So let's say we express x in terms of y, which basically means to get x on one side of the equation and everything else on the other side. So we know that x is equal to 35 plus y. So then, instead of having x plus 2y equals 68, we have 35 plus y plus 2y equals 68. And from here, we can easily figure out that 3y is equal to 33 and y equals 11. And then we can just plug that value right into x equals 35 plus y to find x equals 46. So that is one of the solutions for this system. And another way to solve is to eliminate one of the variables completely by just multiplying the entire equation and then adding or subtracting equations from each other to cancel out certain variables. So if we look at the same example, we can see that first of all, well, there's actually multiple ways to go about this. So we can cancel out y because one of the equations has positive y and the other is negative. So that's one thing you might want to look out for. So if we multiply the second equation by 2, we get 2x minus 2y is 70. And then if we add the top equation, we have x plus 2y plus 2x minus 2y is equal to 3x. And that's going to also equal 70 plus 36, which is just 138. Or sorry, 70 plus 68, not 36. I don't know why I said that. So we got 3x equals 138, or x equals 46. And if we plug this into the second equation, we have 46 minus y equals 35, and y equals 11. So that's another way to solve. And another way you can do this, actually, is to take 68 and subtract 35. We take the first equation and subtract the second. And the reason why this works is because then we just eliminate x entirely, right? We have x plus 2y minus x plus y. So then we're going to have 3y is equal to 68 minus 35. So then we'll just have 33 equals 3y. So y equals 11, and we can just do the same thing as before. So it's pretty much up to you to some extent to decide what method to use, but there's some questions that are specifically designed such that one method is a lot easier than the other. So competitions like the AMC 8 and math counts really emphasize speed, so you want to look out for that. So I'll give you 5 seconds to pause the video and solve this system. So let's see what this problem's all about. So we have this system x plus 2y plus 3z is equal to 27. And then we have 2x plus 3y plus z is equal to 20. And finally 3x plus y plus 2z equals 19. So you can try to solve this by substitution, but this is not really going to work. You want to use elimination here somehow. So how are we going to ever do that? Well, you can notice that each of them cycle through 1, 2, and 3, right? X has these 3 coefficients, so does y, so does z, right? And the key here is to notice if you add all of these, equations, 6x, right, plus 6y plus 6z, and I think you're gonna get, what, 66 here? Then you're going to have x plus y plus z is equal to 11. And the good thing about this is now we can use this to subtract some stuff from our equations. So if we do, for example, the first equation minus this equation, right? Let's call this equation 4. Let's call this 2, 3, right? Then if we have equation 1 minus equation 4, right? That's equal to 27 minus 11, right? Which is equal to 16. And this is also equal to y plus 2z, right? And basically what we're trying to do here is reduce it to a system with only 2 variables, because then it's a lot easier to solve the problem. So another thing we can do is simply multiply this entire thing, right, by 2 times equation 4. And that's going to net us 2x plus 2y plus 2z is equal to 22. And we can do equation 2 minus 2 times equation 4. And that's going to equal, because we want to eliminate everything, all the x's, and we only want to have y and z left. So here we can see that the x's will cancel out, and then we're left with y minus z is going to be equal to 20 minus 22. Which is equal to negative 2. So then we have y plus 2z equals 16. Y minus z is equal to negative 2. So clearly, right, so we have that y is equal to 16 minus 2z, right? And we also know that y is equal to negative 2 plus z. So then we have these two are equal to each other, right? And then we're going to have 18 is equal to 3z and z equals 6. And if z is equal to 6, then if y minus z equals negative 2, then clearly y equals 4. So then, if y equals 4, then this is going to be 8. This is going to be 18. This is going to add up to 26 plus x equals 27. So of course, x is equal to 1. So that is our solution. We have x equals 1, y equals 4, z equals 6. It's always best to check your answers, of course. So if we check the second equation, for example, we'll have 2 plus 12 plus 6, which does indeed equal 20. Or we can have, 3 plus 4 plus 12. This does indeed equal 19, so it's all checked. Now, nonlinear systems of equations can get considerably more difficult. So we'll stick with some simpler ones, like ones involving the terms xy and x squared minus y squared, because these identities can be extremely useful in certain situations like that. So we have x squared minus y squared equals x plus y times x minus y. And of course, all of these can be easily verified by simply multiplying these binomials out. We also have x plus y squared equals x squared plus 2xy plus y squared. And x minus y squared is equal to x squared minus 2xy plus y squared. So remember, x plus y squared is not equal to just x squared plus y squared. You have to have the 2xy term in there as well. And just a little bit more terms. We have x to the third plus y to the third is equal to x plus y times x squared minus xy plus y squared. And x to the third minus y squared equals x minus y times x squared plus xy plus y squared. So the last two might be a bit difficult to remember, but all you have to do is realize if there's a plus sign here, then there's also a plus sign in the binomial and a negative sign in from the xy in the trinomial. And notice the xy does not have a 2 in front of it. It's just xy, no 2. And same for x to the third minus y to the third. The binomial has a negative sign and there's a positive sign in front of the xy in the trinomial. So you can remember it like that. So transforming between x plus y squared and x minus y squared with xy can be really useful. So for example, if x plus y is equal to 13 and xy equals 42, find x minus y. I'll give you 5 seconds to pause the video and find the solution, even though it's right there, but please don't look. Alright, let's see. So we have x plus y is equal to 13. And xy is equal to 42. And some of you might be able to immediately guess the solution. But if you cannot, that's totally fine as well. Because we're going to be showing how to solve this, right? And even if you've guessed it, that's not a rigorous solution, and it's better to know how it works. So let's square both sides of this equation right here. So we have x plus y squared is equal to 13 squared, which, by the way, is equal to 169. So this is going to equal x squared plus 2xy plus y squared. And from what we just learned, we want to find x minus y, right? So if we could just find what x minus y squared is, and then take the square root of whatever that is, then we're done. However, x minus y squared, well, that just so happens to be x squared minus 2xy plus y squared. And immediately we can see a relation between these two. These look very, very similar. So we want to think, how do we get from this equation up here to this equation down here? Well, all we have to do is subtract 4xy, right? So x squared minus 2xy plus y squared. And this is all a part of intuitive mathematical thinking. The more you do problems, the more you will improve your intuition. And resources like Art of Problem Solving, for example, are great for that. So 169 minus 4xy, and we know what xy is. We know that's 42, so we can substitute this as 169 minus 4 times 42. So this is going to equal 1, right? Because 4 times 42 equals 168, and this is going to equal 1. So now that we know that x minus y squared equals 1, then, of course, if we square root both sides, then x minus y is going to either equal 1 or negative 1, right? So plus or minus 1. So there we go. That's the solution. And if you sort of look at it for a bit, you can see, well, x equals 6, y equals 7. That's the solution. And x equals 7, y equals 6 is also a solution. It will satisfy all of these conditions right here. So that's pretty much it for this video. There's not really that much to talk about on systems like these, unless you get to a more advanced level. Next week we will be talking about something more advanced than just these simple systems, so stay tuned for that, and good night. Have a great week, and I'll see you next week.